Hey everyone and welcome back to my channel. In this video I am going to show you a super powerful technique for factoring polynomials, splitting the middle term. Why you have to learn it? Because factoring is the foundation for solving quadratic equation, graphing parabolas and so more much in algebra. So stick with video, watch till end because every part is important. So let's start the video. Factoring polynomials is the process of breaking down a complex polynomial into a product of simpler or lower degree polynomial that when multiplied together produce the original expression. Now factorization of quadratic polynomial x square plus bx plus c by splitting the middle term we will learn. Let's px plus q and rx plus s are factors of ax square plus bx plus c. Then we can write ax square plus bx plus c that is equal to px plus q into rx plus s. Now multiply prx square plus psx plus qrx plus qs, then prx square and take x as a common, we get ps plus qr plus qs. Now comparing the coefficients of x square, x and constant term on both the side, we get coefficients of x square a equal to pr, coefficients of x b equal to ps plus qr, and coefficient of constant term c that is equal to qs. This shows us that b is sum of two numbers ps and qr whose products is ps into qr. Now rearrange it, we get pr into qs that is equal to a into c. Therefore, to factorize ax square plus bx plus c, we have to write b equal to p plus q, sum of two numbers whose product pq is ac, that is constant term into coefficient of x square. Look at some example. Factorize 6 square plus 17x plus 5 by using splitting the middle term. For this, look at the solution. Split the coefficient of middle term 17 in two numbers p and q such that p plus q equal to 17 and pq equal to 5 into 6 equal to 30. Now we have p plus q equal to 17, that is equation 1, and pq that is equal to 30, that is equation 2. Thereafter, for getting value of p and q, we have to find p minus q. For this, we can write p minus q ke the whole square equal to p plus q ke the whole square minus 4pq. Now, put equation 1 and equation 2 in this expression. We get p minus q ke the whole square that is equal to 17 square minus 4 into 30, that will be 289 minus 120, that is equal to 169. So p minus q ke the whole square that is equal to 169. Now p minus q equal to square root of 169. Then p minus q equal to plus minus 13, that is equation 3. Add equation 1 and equation 3 taking p minus q equal to 13, that will p plus q equal to 17 and p minus q that will 13. Add this, plus q and minus q will get cancelled, then we get 2p equal to 30 and p equal to 30 divided by 2, that is equal to 15. Put value of p in equation 1, we get 15 plus q equal to 17. So q equal to 17 minus 15, that is equal to 2. Add equation 1 and equation 3 taking p minus q that is equal to minus 13, then p plus q that is equal to 17 and p minus q that is minus 13. Now add this, plus q and minus q will get cancelled, we will get 2p that is equal to 4, then p equal to 4 divided by 2, that is equal to 2. Now put value of p in equation 1, we get 2 plus q that is equal to 17. So q equal to 17 minus 2 equal to 15. From above calculation, we find out p equal to 15 and q equal to 2, or p equal to 2 and q equal to 15 given quadratic polynomial, that is 6 square plus 17x plus 5. 17 can be split as 15 or 2 or 2 or 15. So we can write 6x square plus 2x plus 15x plus 5. Now take 2x as a common, we get 3x plus 1, and then taking 5 as a common, we get 3x plus 1. Now we will take 3x plus 1 as a common, then we will get 2x plus 5. Therefore 3x plus 1 and 2x plus 5 is factor of given polynomial. Now we will try to solve with another method, that is second method. Given quadratic polynomial, that is 6x square plus 17x plus 5, split the coefficient of middle term 17 in two numbers such that sum of numbers equal to 17 and product equal to constant term into coefficient of x square, that is equal to 5 into 6 equal to 30. First factor of 30 and make pairs, then factor of 30 equal to 1, 2, 3, 5, 6, 10, 15 and 30. Take a pair of numbers such that sum equal to 17. Here we can see 2 plus 15 equal to 17. So 6x square plus 17x plus 5, now that can be written as 6x square, 2x plus 15x and plus 5. Now take 2x as a common, we get 3x plus 1, and taking 5 as a common, we get 3x plus 1. Now take 3x plus 1 as a common, we get 2x plus 5. Now chapter 2 exercise 2.3. For this, look at question number 1. Determine which of the following polynomials has x plus 1 as a factor. For this solution, as we know by factor theorem, x minus a is a factor of px if and only if pa equal to 0. Now calculate 0 of given linear polynomial by putting x plus 1 equal to 0, then x equal to minus 1. Now x plus 1 is a factor of px if p minus 1 equal to 0. For this, first polynomial is x cube plus x square plus x plus 1. Then putting minus 1, we get minus 1 to the power cube plus minus 1 square plus minus 1 plus 1. That will be minus 1 plus 1 minus 1 plus 1, that is equal to 2 minus 2, that is equal to 0. Here p minus 1 equal to 0. So we can say x plus 1 is a factor of above polynomial px. Another polynomial, that is x to the power 4 plus x cube plus x square plus x plus 1. Now put p minus 1, we get minus 1 to the power 4 plus minus 1 cube plus minus 1 square plus minus 1 plus 1. Now 1 plus minus 1 plus 1 minus 1 plus 1, that is 3 minus 2, that is equal to 1. Here p minus 1 equal to 1, not equal to 0. So by factor theorem, x plus 1 is not a factor of a above given polynomial px. Look at another polynomial expression px, that is x to the power 4 plus 3x cube plus 3x square plus x plus 1. Now put p minus 1, we get minus 1 to the power 4 plus 3 into minus 1 cube plus 3 into minus 1 square plus minus 1 plus 1, that will be 1 plus 3 into minus 1 plus 3 into 1 minus 1 plus 1, then 1 minus 3 plus 3 minus 1 plus 1 plus 3 and minus 3 will get cancelled, and minus 1 and plus 1 will get cancelled. We get 1. Here p minus 1 equal to 1, that is not equal to 0. So by factor theorem, x plus 1 is not a factor of above polynomial px. Now look at another polynomial expression px, that is x cube minus x square minus 2 plus root 2x plus root 2. Then put p minus 1, we get minus 1 to the power cube minus minus 1 square minus 2 plus root 2 into minus 1 plus root 2. Then minus 1 plus 2 plus root 2 plus root 2, that will be 2 root 2 minus 2 and plus 2 minus 2 and plus 2 will be cancelled, we get 2 root 2. Here p minus 1 equal to 2 root 2, that is not equal to 0. So by factor theorem, x plus 1 is not a factor of above polynomial px. Question number 2, that is use the factor theorem to determine whether gx is a factor of px in each the following cases. For this, look at solution. First polynomial is px equal to 2x cube plus x square minus 2x minus 1 and gx equal to x plus 1. As we know by factor theorem, gx equal to x minus a is a factor of px if and only if pa equal to 0. So firstly find 0 of gx by putting gx equal to 0. So gx that is equal to x plus 1 equal to 0, then x equal to minus 1. Now put 0 of gx equal to minus 1 in given polynomial px that is equal to 2x cube plus x square minus 2x minus 1. So p minus 1 that is equal to 2 into minus 1 power cube plus minus 1 square minus 2 into minus 1 that will be 2 into minus 1 plus 2 minus 1 that is minus 2 plus 1 plus 2 minus 1. Now minus 2 and plus 2 will cancel and plus 1 and minus 1 will cancel, we get 0. By factor theorem, since p minus 1 equal to 0, then gx is a factor of px. Another polynomial px that is equal to x cube plus 3x square plus 3x plus 1 and gx that is equal to x plus 2. So gx equal to x plus 2 equal to 0 and x equal to minus 2. Now put 0 of gx equal to minus 2 in given polynomial px and px equal to x cube plus 3x square plus 3x plus 1. So p minus 2 that is equal to minus 2 the power cube plus 3 into minus 2 square plus 3 into minus 2 plus 1 that will be minus 8 plus 3 into 4 minus 6 plus 1 that will be minus 8 plus 12 minus 6 plus 1 that is equal to minus 14 plus 13 that is equal to minus 1. By factor theorem, since p minus 2 not equal to 0, so gx is not a factor of px. Now look at another polynomial px that is equal to x cube minus 4x square plus x plus 6 and gx equal to x minus 3. So gx equal to x minus 3 equal to 0, then x that is equal to 3. Now put 0 of gx equal to 3 in given polynomial px that is equal to x cube minus 4x square plus x plus 6. So p3 that is equal to 3 to the power cube minus 4 into 3 square plus 3 plus 6 that is equal to 27 minus 4 into 9 plus 9 that is equal to 27 minus 36 plus 9 that is equal to 36 minus 36 that is equal to 0. By factor theorem, since p3 equal to 0, gx is a factor of px. Question 3. Find the value of k if x minus 1 is a factor of px in each of the following cases. For this, look at solution. First question is px equal to x square plus x plus k. If x minus 1 is a factor of px, then by factor theorem, p1 equal to 0. So p1 that is equal to 1 square plus 1 plus k equal to 0. That implies 1 plus 1 plus k that is equal to 0. That implies 2 plus k that is equal to 0. Therefore, k equal to minus 2. Now, px equal to 2x square plus kx plus root 2. If x minus 1 is a factor of px, then by factor theorem, p1 equal to 0, then p1 that is equal to 2 into 1 square plus k into 1 plus root 2 that is equal to 0. That implies 2 plus k plus root 2 that is equal to 0. That implies k equal to 2 minus root 2. Therefore, k equal to 2 minus root 2. Another polynomial px that is equal to kx square minus root 2x plus 1. If x minus 1 is a factor of px, then by factor theorem, p1 equal to 0. Now p1 that is equal to k into 1 square minus root 2 into 1 plus 1 equal to 0. Then k minus root 2 plus 1 equal to 0. That implies k equal to root 2 minus 1. Therefore, k equal to root 2 minus 1. Another polynomial px that is equal to kx square minus 3x plus k. If x minus 1 is a factor of px, then by factor theorem, p1 equal to 0. So p1 that is equal to k into 1 square minus 3 into 1 plus k that is equal to 0. Then k minus 3 plus k equal to 0. That implies 2k minus 3 equal to 0. that imply 2k equal to 3, that imply k equal to 3 by 2, therefore k equal to 3 by 2. Now question 4. Factorize. First, 12x square minus 7x plus 1 given polynomial is quadratic, so use middle term split. Constant term into coefficient of x square, that is equal to 12 into 1 equal to 12. Now factor of 12, that is equal to 1, 2, 3, 4, 6 and 12. Here pair 4 and 3 satisfy. 4 plus 3 equal to 7 and 4 into 3, that is equal to 12. So 12x square minus x into 4 plus 3 plus 1, that imply 12x square minus 4x minus 3x plus 1. Now take 4x as a common, we get 3x minus 1, and taking minus 1 as a common, we get 3x minus 1. Now 3x minus 1 taking common, we get 4x minus 1. Therefore 3x minus 1 and 4x minus 1 is factor of given polynomial. Another question, that is 2x square plus 7x plus 3 given polynomial is a quadratic, so use middle term split. Now constant term into coefficient of x square, that is equal to 3 into 2 equal to 6. So factor of 6, that is equal to 1, 2, 3 and 6. Here pair 6 and 1 satisfy. 6 plus 1 equal to 7 and 6 into 1 equal to 6. So 2x square plus x into 1 plus 6 plus 3. Now 2x square plus x plus 6x plus 3. Take x as a common, we get 2x plus 1. Now take plus 3 as a common, we get 2x plus 1. Now take 2x plus 1 as a common, we get x plus 3. Therefore 2x plus 1 and x plus 3 is factor of given polynomial. Third one, that is 6x square plus 5x minus 6 given polynomial is quadratic, so use middle term split. Constant term into coefficient of x square, that is equal to minus 6 into 6 equal to minus 36. Now factor of minus 36, that is plus minus 1 plus minus 2 plus minus 3 plus minus 4 plus minus 6 and plus minus 9 plus minus 12 plus minus 18 and plus minus 36. Here pair 9 and minus 4 satisfy. 9 plus minus 4, that is equal to 5, and 9 into minus 4 equal to 36. So we can write 6x square plus x into 9 plus minus 4 minus 6, that is equal to 6x square plus 9x minus 4x minus 6. Now take 3x as a common, we get 3x plus 3, and taking minus 2 as a common, we get 3x plus 3 again. Then take 2x plus 3 as a common, we get 3x minus 2. Therefore 2x plus 3 and 3x minus 2 is a factor of given polynomial. Now another polynomial is 3x square minus x minus 4 given polynomial is quadratic, so use middle term split. Constant term into coefficient of x square, that is equal to minus 4 into 3 equal to minus 12. Now factor of minus 12, that is equal to plus minus 1 plus minus 2 plus minus 3 plus minus 4 plus minus 6 and plus minus 12. Here pair 4 and minus 3 satisfy. 4 minus 3 equal to 1 and 4 into minus 3, that is equal to minus 12. Now 3x square minus x into 4 plus minus 3 minus 4, that can be written as 3x square minus 4x plus 3x minus 4. Taking x as a common, we get 3x minus 4, and taking plus 1 as a common, we get 3x minus 4. Now taking 3x minus 4 as a common, we get x plus 1. Therefore 3x minus 4 and x plus 1 is factor of given polynomial. Question number 5. Factorize. First question, x cube minus 2x square minus x plus 2. Solution. Firstly find factor of constant term 2, that is plus minus 1 and plus minus 2. Now put 1 by 1 in px by factor theorem. If a equal to 0, then x minus a will be factor. Put p1 in px, we get 1 cube minus 2 into 1 square minus 1 plus 2, that will be 1 minus 2 minus 1 plus 2, that will be 3 minus 3, that is equal to 0. Therefore, x minus 1 is factor of given polynomial. Now, put p minus 1, then we get minus 1 to the power cube minus 2 into minus 1 square minus 1 plus 2, that will be minus 1 minus 2 plus 1 plus 2, that will be minus 3 plus 3, that is equal to 0. Therefore, x plus 1 is factor of given polynomial. Now put 2p2, that is equal to 2q minus 2x square minus 2 plus 2, that will be 8 minus 2 into 4 minus 2 plus 2, that 8 minus 8 minus 2 plus 2, that will be 10 minus 10, that is equal to 0. Therefore, x minus 2 is a factor of given polynomial. Now put p minus 2, that is equal to minus 2 to the power cube minus 2 into minus 2 square minus 2 plus 2, that will be minus 8 minus 2 into 4 minus 2 plus 2, that will be minus 8 plus 2 plus 2, that will equal to minus 16 plus 4, that is equal to minus 12. Here p minus 2 not equal to 0, so x minus 2 is not a factor of given polynomial. Second method, for any single variable polynomial px p1 is just the sum of coefficient. If the sum of coefficient is 0, then f1 equal to 0, which means 1 is 1 0 and x minus 1 will be one factor of px. Given polynomial x cube minus 2x square minus x plus 2, sum of coefficient, that is equal to 1 plus minus 2 plus minus 1 plus 2, that is equal to 1 minus 2 minus 1 plus 2, that is equal to 3 minus 3, that is equal to 0. Therefore, x minus 1 is factor of given polynomial. Use long division method. So, x minus 1 divides x cube minus 2x square minus x plus 2, then first with x square, then after multiplication with divisor we get x cube minus x square. Now minus subtract, we get changes in sign, then after we get minus x square minus x plus 2. Now with minus x after divisor multiplication we get minus x square plus x, sign will change it. Then after subtract we get minus 2x plus 2. Now with minus 2 we get minus 2x plus 2. After subtraction we get 0 as a remainder. As we know, dividend equal to divisor into quotient plus remainder. X cube minus 2x square minus x plus 2, that is equal to x minus 1 into x square minus x minus 2 plus 0. Now factor of minus 2 plus minus 1 and plus minus 2, pair 1 minus 2 satisfy the condition that 1 plus minus 2 equal to minus 1 and 1 into minus 2 equal to minus 2. So x minus 1 into x square minus 2x plus x minus 2, that will be x minus 1, taking x as a common, then x minus 2 and taking plus 1 as a common, we get x minus 2. Now x minus 1, taking x minus 2 as a common, we get x plus 1. Therefore x minus 1 into x minus 2 into x plus 1. Third method, taking common. Now x cube minus 2x square minus x plus 2, take x square as a common, we get x minus 2. Then take minus 1 as a common, we get x minus 2. Now taking x minus 2 as a common, we get x minus 2 into x square minus 1. Now x cube minus 2x square minus x plus 2, that is equal to x minus 2 into x plus 1 into x minus 1. Now question 2, x cube minus 3x square minus 9x minus 5. Add coefficients, we get 1 minus 3 minus 9 minus 5, that is equal to 1 minus 17, that is equal to minus 16, that is not equal to 0. So we can say x minus 1 is not a factor of given polynomial. Now find factor of constant term minus 5, that is plus minus 1 and plus minus 5. Now put 1 by 1 in px by factor theorem. If pa equal to 0, then x minus a will be factor. As we have seen, x minus 1 is not a factor of given polynomial. So let's try putting x equal to 5, then 5 cube minus 3 into 5 square minus 9 into 5 minus 5, that is equal to 125 minus 3 into 25 minus 45 minus 5. That implies 125 minus 75 minus 45 minus 5. That implies 125 minus 125, that is equal to 0. Now x minus 5 is the one of the factor of given polynomial. Now use long division method, taking x minus 5 as a divisor, x cube minus 3x square minus 9x minus 5 as a dividend. Now x minus 5 will divide x cube minus 3x square minus 9x minus 5. First with x square multiplied with divisor, we get x cube minus 5x square. During subtraction, sign will change it. Then after subtraction, we get 2x square minus 9x minus 5. Now with plus 2x, we get 2x square minus 10x. During subtraction, again sign will change it, and then we get x minus 5. Now with plus 1, we get x minus 5, and after subtraction, we get sign will change it, and after subtraction, we get 0 as a remainder. As we know, dividend equal to divisor into quotient plus remainder. So x cube minus 3x square minus 9x minus 5, that is equal to x minus 5 into x square plus 2x plus 1 plus 0. Then x minus 5 into x plus 1 get the whole square. Therefore, x minus 5, x plus 1 and x plus 1 is a factor of given polynomial. Third one, that is x cube plus 13x square plus 32x plus 20. Now find factor of constant term 20, that is 1, 2, 4, 5, 10, 20. Now put 1 by 1 in px by factor theorem. If pa equal to 0, then x minus a will be factor. So let's try putting x equal to minus 1, then minus 1 cube plus 13 into minus 1 square plus 32 into minus 1 plus 20, that is equal to minus 1 plus 13 into 1 minus 32 plus 20, that will be 33 minus 33, that is equal to 0. Therefore, x plus 1 is factor of given polynomial. Use long division method. For this, x plus 1 divide x cube plus 13x square plus 32x plus 20. First with x square multiplied with divisor x plus 1, we get x cube plus x square. Now subtract. During subtraction, sign will change it. Then after subtraction, we get 12x square plus 32x minus 20. Then with plus 12x, we get 12x square plus 12x. Now sign will change it, and after subtraction, we get 20x plus 20. Now with plus 20, we get 20x plus 20. Now after subtraction, we get 0 as a remainder. As we know, dividend equal to divisor into quotient plus remainder. X cube plus 13x square plus 32x plus 20, that is equal to x plus 1 into x square plus 12x plus 2 and plus 0. Now factor of 20, that is equal to plus minus 1 plus minus 2 plus minus 4 plus minus 5 plus minus 10 plus minus 20. Pair 10 and 2 satisfy the condition that 10 plus 2, that is equal to 12, and 10 into 2, that is equal to 20. That imply x plus 1 into x square plus 10x plus 2x plus 20. Now x plus 1, taking x as a common, we get x plus 10, and taking plus 2 as a common, we get x plus 10. Now x plus 1 into x plus 10 take common, we get x plus 2. Then x plus 1 into x plus 10 into x plus 2. This is a factor. Now 2y cube plus y square minus 2y minus 1, taking y square as a common, we get 2y plus 1, and taking minus 1 as a common, we get 2y plus 1. Then y square minus 1 into 2y plus 1. Now use identity x square minus y square, that is equal to x plus y into x minus 1. That imply y plus 1 into y minus 1 into 2y plus 1. Therefore, y plus 1, y minus 1 and 2y plus 1 is factor of given polynomial. Here we ending today. Thanks for watching video. Like, share and subscribe please.